Hi, I'm Abhi.
Hi, I'm Rishi, and we're the co-founders and developers at Opennote. And as second-year STEM students at university, we take a ton of classes. And a lot of them have thousands of enrolled students and a small instruction team to sort of orchestrate it all. And for students trying to juggle classes and apply complex content, sometimes it's difficult to truly grasp the content in a way that they understand. And so we interviewed students and professors to sort of get an idea of how we could make higher education more personalized and interactive for everyone.
Yeah, so we started Opennote in early 2024 when we were first years competing at UCLA's hackathon, and we were able to develop a pretty solid MVP in just about 40 hours. And we got a lot of great feedback and ran an open beta run where we got 300 users in less than 5 days. And after testing those waters, we thought that things didn't feel right just yet. So now we've rebuilt the platform from the ground up and partnered with Desmos and integrated a bunch of things that students really value to make education more interactive.
So let's just dive right into the platform and give you a live demo. So I took a differential equations class last year, which loved the professor, loved the class, loved everything about it. But I'm not gonna lie, I was kind of lost. So I'm gonna make a space and open up, just kind of get some help with differential equations.
Awesome.
Okay, so if I start with a little bit of a general overview of explain differential equations to me.
Awesome.
And here we get sort of an overview of differential equations from Feynman. And so from here, I can kind of dive a little bit deeper and kind of get a true feel of really Opennote's interactivity. And say, plot a phase diagram for me. And so from here, we get a phase diagram of a predator-prey model, as well as some plots in our Desmos graph of really getting a better visualization of what this actual problem is.
Yeah. So I can actually jump right in and show a little bit more about how you can interact with the graph. So let's say we had another equation, and I'll just give it something pretty simple. We'll say dy dt equals kt, and that's like a pretty basic differential equation to solve, and that's something you're starting off with in these classes. So let's ask it how or what equation is on my graph. Great. And so once we get this back, we'll get some details on what I wrote down, how we can solve it, and how it's a first order linear differential equation. So now let's go in and let's actually ask it a video to get a bit of a deeper understanding of what we want to learn about. So I'll say, explain Laplace transform differential equations to me with a video. Awesome. So while we're waiting for this video, we can provide a bit more detail on why we built Feynman, how we built Feynman, and how everything works. So Feynman is our solution to not just providing an AI model that can teach you the answer, but really focusing in on the teachability of the product and also being able to have students gain a deeper understanding of whatever they're doing when interacting with Opennote. And so what that means is we've trained Feynman in such a way that it's really going to explain to you what you want to know, rather than other models such as GPT-4, which are just trying to get you off the site with your result as soon as possible. And I think Rishi can also dive a bit more into what Feynman interacts with.
All right, so a big part of the interactivity we try to focus on with Feynman is Desmos, but also another part of that is the whiteboard we've integrated. Yeah. And so with the whiteboard, you can sort of draw things in the same way that Feynman can read from your Desmos graph and write to your Desmos graph. It can do the same with whiteboards. Yeah. And so that sort of opens up a whole new realm of what you can use Opennote for and how interactive you can truly be with the site and make it personal to you.
Awesome. So now that we got the video back, we can actually play back some of this and see what Opennote and Feynman were able to give us.
Imagine a video showing a complex differential equation on the screen with the Laplace transform symbol denoted as L.
Awesome. So yeah, as you can see, we got some details explaining how Laplace transforms work. And if we scrub ahead a little bit in the video, we'll get a lot of information on what it's trying to do and how the concept works at a deeper level than what other models might be able to teach it to you as. And going back to that idea of whiteboards, we can actually dive back into that. So if Rishi, you want to do a little demo in a new space about how whiteboards work.
Yeah, so as you can see, the whiteboard I've drawn on the side is actually from one of my CS classes. I was drawing a binary tree trying to find out how to traverse it. So you can kind of use that as a sort of demo here.
Awesome.
And so I can kind of ask Feynman, what's on my whiteboard?
Uh-huh.
And it'll give me something back. And from there, we can explore different ways to traverse it and really integrate it more into my programming assignment and whatever the task might be. And so that's kind of the beauty of what we designed Opennote for, is to make it as interactive and immersive as a learning experience as it can be, and make it as easy as possible to integrate into your studies.
Yeah.
And so from here, I can kind of ask Feynman.
Awesome. So once we get this back, we'll actually be able to see the code, and then we can run this inline as well. So students will be able to get the output of their tree traversal, and soon enough, they'll also be able to edit it right here. And that's going to really promote interactivity in CS learning. But Opennote's not just built for STEM, and we're really making sure that all students can succeed on the platform with being able to be as creative as possible with whatever query they want to put in.
All right. So we fully launched Opennote a few days ago, and it's been going great. But we'd love to hear your feedback. So give the platform a shot and let us know what you think.
Thanks for your time.